911 emergency.
I need a unit, sugar fighting now. It just blew up. It just blew up. I need all 5 units to the sugar refinery now. It's a full fire. It blew up.
At 7:15 p.m. on February 7, 2008, a violent explosion erupted at the Imperial Sugar Refinery in Port Wentworth, Georgia, just outside Savannah. Surveillance cameras in the area captured the blast, which took the lives of 14 workers and injured 38 others. The Chemical Safety Board launched an investigation. The fuel for the blast? Combustible dust.
Combustible dust can be a catastrophic hazard in American industry. 3 of the 4 most serious accidents that we've investigated have been combustible dust explosions.
In 2006, this pattern of accidents spurred the CSB to issue a comprehensive study of combustible dust, which uncovered 281 fires and explosions that had occurred over the previous 25 years. The study revealed what the CSB called a significant industrial safety problem.
No company wants to see its facility blown up and destroyed and its employees killed, but they just don't understand what the hazard is. They don't realize that they have a hazard here until that one day when the explosion occurs, and it's a terrible tragedy for them. And they look back and say, if we'd only known.
The company produced aluminum car wheels. The process of finishing the wheels left behind aluminum scraps, which were chopped into small pieces and sent to a furnace to be melted and reused. Chopping, drying, and blowing the dry chips through the transfer piping created highly combustible aluminum dust, which flowed through ducting to a steel drop box outside the building, where large particles were trapped. The air then entered a dust collector, which removed finer aluminum particles. Over time, aluminum dust accumulated inside ducts. In addition, there were leaks in the piping used to transfer aluminum chips, which caused dust to build up on surfaces throughout the furnace area. Aluminum dust landed on beams, ledges, and equipment. In some places, the dust was several inches deep. On the night of October 29th, about 10 minutes after workers started the aluminum chip melting process, aluminum dust inside the dust collector was suddenly ignited, perhaps by a metal ember or impact spark, resulting in a large explosion. The blast propagated back through the duct into the steel drop box, blowing it apart. The fireball and pressure wave continued back through the duct system into the building, gaining intensity as the accumulated aluminum dust ignited. The violent disturbance shook loose dust that had built up on external surfaces. At about 8:30 p.m., plant mechanic Sean Boone was one of several workers in the area of the furnace. Without warning, a fireball erupted from the furnace, engulfing the area and igniting airborne dust in a second, larger explosion. The explosion blew a 50-foot wide hole through the roof of the building.
The issue of combustible dust explosions is not focused on one particular industry. It happens right across all industries, and industries that where you perhaps wouldn't expect there to be an explosion.
Industries at risk include food production, metal processing, wood products, chemical manufacturing, rubber and plastics, and coal-fired power plants.
What is so frustrating about dust explosions is that they're so preventable. And I believe that one of the reasons that dust explosions continue to occur may simply be a lack of understanding about the materials. Most solid organic materials will explode if the particles are small enough and they're dispersed in a sufficient concentration. Some of the materials that could form combustible dust, and there are lots of them, could include coal, sawdust, food products like sugar and flour, pharmaceuticals, many chemicals, and even many metals.
Like all fires, a dust fire requires fuel oxygen, and an ignition source. A dust explosion requires two additional elements: dispersion and confinement. The CSB commissioned laboratory tests using a sample of fine polyethylene dust found by investigators in the rubble of a North Carolina factory. Dust is dispersed into a flame, creating a fireball. When the dust is confined within a structure or a piece of equipment, a powerful explosion can occur and propagate, as this coal industry video demonstrates. Dust may accumulate on surfaces and lie undisturbed for years. Then some initial fire or explosion, known as a primary event, shakes it loose and ignites it.
It causes a pressure wave to go through the plant, and that dislodges all of the dust that is perhaps unknown up on the rafters, on the beams, on the tops of equipment, and that serves as the fuel for the secondary explosions that move through the plant.
Most of the fatalities and the devastating injuries have been caused by these secondary dust explosions.
According to the NFPA, a catastrophic explosion can occur from as little as 1/32 of an inch of accumulated dust, around the thickness of a dime, covering just 5% of a room's surface area. A catastrophic dust explosion at the West Pharmaceutical plant in Kinston, North Carolina in 2003 reveals what can happen when companies do not properly assess the hazards from combustible powders and do not design their buildings and equipment appropriately. West Pharmaceutical made small rubber medical products, such as syringe plungers and stoppers, at a large manufacturing facility with nearly 300 workers. In the process, large batches of rubber were compounded and rolled into long strips. To keep these strips from sticking together, they were dipped in a vat containing a whitish slurry of water and finely powdered polyethylene, a petroleum-based wax-like plastic. The coated rubber strips were then blown dry with fans and folded for later processing. As the rubber sheets dried, combustible polyethylene dust, which was not visible to workers but is colored white here for illustration, was blown into the air. Over the years, the air conditioning system drew polyethylene dust into the hidden space above an acoustic tile ceiling that was suspended over the production area. There, the dust gradually built up to a thickness of up to 1/2 inch on ceiling tiles, beams, conduits, and light fixtures, just a few feet over the heads of unsuspecting workers. January 29th began as a routine workday at the West plant. But at about 1:28 p.m., a small fire or explosion occurred somewhere near the production area. It lofted the accumulated dust above the ceiling into a thick cloud, which then ignited in a much more violent secondary explosion. Some employees described a sound like rolling thunder as the dust explosion spread throughout the space above the ceiling and ripped through the building. The accident at West Pharmaceutical Services took the lives of 6 employees and injured 38 others, including 2 firefighters.
The thing that set up the tragedy at West was the mere accumulation of hazardous dust above a ceiling.
Another cause of the West accident was that workers were not informed of the dust explosion hazard arising from the polyethylene slurry, a fact that should have been included on the material safety data sheet. Jim Don is a leading expert on combustible dust.
If you got a dust, you need to know what the ability of that dust is to explode, and to be able to characterize that dust in terms of, does it take a little energy? Does it take a lot of energy to ignite it? Will this dust, when it explodes, create a very major overpressure? Those are the things that need to be onto a MSDS.
Less than a month after the West Pharmaceutical accident, a fatal dust explosion crippled the CTA acoustics plant in Corbin, Kentucky. The disaster at CTA, which claimed 7 lives, illustrates the critical importance of following NFPA recommended practices to control dust hazards. The CTA facility, with more than 500 personnel, produced fiberglass acoustic insulation for automobiles. Covering 300,000 square feet, it had 5 production lines. At line 405, fiberglass was fed along a conveyor system and spread to create a web. Black phenolic resin powder was deposited onto the fiberglass. Hundreds of thousands of pounds of the combustible resin powder were used in the plant every month. Next, the mat former used air suction to spread the resin through the fiberglass. Excess powder and fibers were drawn up into a dust collector and rapidly accumulated on long cloth bags. After the mat former, a nylon facing was rolled onto the fiberglass before it entered a gas-heated curing oven. Combustible resin accumulated in the oven, resulting in frequent small fires that were extinguished by workers. During each shift, the line was shut down for cleaning. On the roof, employees routinely used compressed air to dislodge dust that had built up in the ductwork, dumping the material into a large open box on the production floor. On the production line, workers also used compressed air to blow dust off equipment. They swept the production floor with brooms. These cleaning activities created dust clouds so dense that large fans were used to blow the dust away from the operators. This increased the dispersion of dust in the plant. The dust settled on horizontal surfaces throughout the entire production area. Over years of operation, dust built up on top of pipes, electrical conduits, and other hard-to-clean elevated surfaces such as roof trusses. A pile of resin dust more than a foot deep had built up on top of the blend room due to periodic cleaning of clogged equipment. On the morning of February 20th, 2003, production line 405 was shut down for routine cleaning. The oven was still on, with one of its doors left open to control the temperature because the oven thermostat had broken weeks earlier. CSB investigators later determined that most likely a small fire, unseen by workers, had started inside the oven, fueled by a buildup of combustible resin. During cleaning, workers had discovered that a transition duct leading from the mat former to the dust collector was clogged. They used a compressed air lance to dislodge the material back through cleanout doors into the production area. Together with other cleaning activities, this created a dense dust cloud around line 405. A wall fan blew the cloud toward the open oven. The dust was ignited by the small fire inside. Flames erupted from the oven, igniting the larger dust cloud, which exploded. This was quickly followed by a second dust explosion at the other end of the production line. 4 employees nearby were injured. 1 later died from severe burns. The force of the 2 explosions shook the building and dispersed accumulated dust throughout the production area. This airborne dust fueled a quickly moving fireball, spreading west along the roof trusses toward production line 403, which was also surrounded by dust. 4 workers in this area were fatally burned. The fireball continued past line 402, fatally injuring 2 more workers, and then to line 401, where a third explosion occurred nearly 300 feet from where the first blast was ignited. 3 workers in this area were severely burned.
The 4 production lines were not adequately segregated, and this allowed the dust explosion to very quickly travel from one production line to the next to the next. And in this case, most of the employees who died were actually working a far distance from where the initial fire began.
This video will take the lesson that they really need to do something to prevent combustible dust explosions.